All right, this section is on limits. And what we're doing is we're talking about the limit of a graph as x approaches a number. So on this first one here, so on A, we're talking about the limit as x approaches 3. And when we see that this little negative sign, what that means is the limit of as x approaches 3 from the left. Okay, so we are looking at this part of the graph right here. So we are looking at as you move from the left, and you were looking at the y value. So the y value here is going to be 2. All right, so on B, right here, is as x approaches 3 from the right. So down here, this graph exists. There's a part of the graph that exists as you approach it from the right. So the y value down here, your y value is -2. Now, notice on this one, there is no sign right here, okay? So if the y value is not the same, then you're basically looking like from either side. So you're basically looking from both sides. Now, if it's not the same, if your y value is not the same, we say does not exist. And it's basically because they don't match. The y values don't match. All right, now on this one, what is it when the x value is exactly 3? So think of it as this has to be a closed circle or an exact point, okay? So basically we're looking at this one right here, and our y value is 1. Okay, so let's look at this one. All right, so again on this one, we're looking at the limit as x approaches -2 from the left. All right, so as we look at it, we're looking at as x approaches 2 from here. So our y value here is going to be 2. As x approaches -2 from the right, so as we approach it going this direction, the y value is also going to be 2. As x approaches -2, so on this one it's from either side. Now in this case it is the same, so our value is 2. And as if f equals -2, again we're looking for a closed circle or a point. Now this is a definite point. It's not an open like this right here. It is not an open circle. It is a point. So our answer for that one would also be 2. All right, so on number 3, as the limit approaches 1 from the left, so if we are approaching the value of x equals 1 from the left, so we're going this way. So this graph here is like that's what we're focusing on. Our value is 3, okay? On the next one is the limit approaches 1 from the right side. So it's like we're following this line. So we're looking at that part. We're looking at this part of the graph. So that y value is a 2, all right? So in part C, we're looking at it from either side. That's going to be does not exist because they don't match. And you don't have to write down don't match. You just have to put does not exist. And then the value at f of 1, so again, you're looking for that closed circle or that definite point. That value is going to be 2 because, again, we're looking for that point right there. Okay, so on this one, the limit as x approaches 0 from the left. So if we look, if we just start and go from the left, so right there, that would be -3. As we approach 0, so part C here, as we approach 0 from the right, so we're going from this side. So again, that's also going to be -3. So on D, as we approach from either side, so these are the same, so that would also be -3. And then F of 0, well, that right there, even though it doesn't have like a big point right there, but it's not an open circle, that would also be -3. Okay, so on this one, as x approaches 0 from the left, so if we follow this graph from the left, that's going to be 3. As x approaches 0 from the right, so we got to go the graph from the right, that's going to be a -2. And as x approaches 0 from either side, that's going to be does not exist because those values are not the same. And if f equals 0, or f of x, if it's equal, if the x is 0, we have to say that that is 3 because we're looking at that open circle. All right, on this next one here, the limit approaches 2 from the left. So we're looking at the graph going from the left. So here, if we follow this graph here, so we look at this point there, so that's going to be 1. If we follow the graph from the right, so you have to look at where the line is on the right, so go in this direction here, that is also a 1. All right, the graph from either side, so since those are the same, we can say 1. Now, where is the x value is 2, we have to go by this the closed circle, so that value would be 3. We can't use that open circle. Okay, so now we're actually given some functions here. We're actually given like equations to plug it into. So when we're given these equations here, you must get a finite answer. So let's make that note. You must get a finite answer. Okay, we can't get like a 0 on the bottom of a fraction or a negative in the square root. And so we're looking at we have not 3 strategies, we have about 4 strategies, and we're basically, we're going to look at 2 main ones. So we're just going to focus on 2 main ones. So we will just focus on plugging in, and we will try factoring. Those are the 2 that we are going to focus on for these sets of notes. So on the first one, what you do is you take what the limit is approaching, and we're just going to plug it in. So we have 3, plug in -1/2, and then that's squared, and then 2 times -1/2 minus 1. And so now we have 3 times 1/4, and then actually let's go ahead and do 2 times 1/2. So that's going to give us a -1 minus 1. And so we have 3/4 times -2, which will give us -3/2. And that's our answer. We get a number, we get a finite answer for our number, and so that's what the limit approaches. So for number 8, on this one, we'll just simply plug in this -4. So we have -4 plus 3 to the power of 1997. Well, -4 plus 3 is going to give me a -1. And we know anything to an odd power will end up being negative. So that comes out to be a -1. And that's a finite answer, so that's a finite number, so that's our answer. All right, if I plug in -3 on this one, we have -3 squared plus 4 times -3 plus 3 over -3 squared minus 3. Okay, so as we simplify this part here, we will have -3 squared is going to be 9, and then minus 12 plus 3 over, and then we'll have 9 minus 3 on the bottom. And then 9 minus 12 plus 3, that is going to give us a 0 on top over 6. Now, it is okay to have a 0 on top. We just don't want a 0 on the bottom of a fraction. And this will turn into a 0. So this is a finite number, so we are okay with this. So again, we just don't want a 0 on the bottom. All right, on number 10, if we plug in a 0, we have e to the power of 0 times the cosine of 0. Well, e to the power of 0 is 1, and the cosine of 0 is 1, and 1 times 1 is 1. On the next one here, if we plug in negative 2, we have the square root of negative 2 minus 2. Well, negative 2 minus 2 is negative 4. We can't have the square root of a negative number. We get into imaginary numbers, and we just don't deal with that in limits. So this limit does not exist. So we just can't have that. On the next one here, if we plug in a 0 on the bottom of a fraction, we get 1 over 0 squared. Well, we can't have a 0 on the bottom of a fraction. Normally, we would talk about factoring, but this one, it can't be factored. There's nothing that we can do with this. So this is another one that does not exist. This limit does not exist. Now, on this one, if I plug in a 1, if I look at this bottom part here, now I'm just looking at the denominator. If I do 1 squared minus 1, I get a 0. I get a 0 on the bottom. I can't have a 0 on the bottom. But if I factor this, so on problems that you can, now on 11 and 12, there was nothing else that we could do. But on this one, we can actually factor. So let's factor this one and look at what happens. X squared minus 1 is a difference of perfect squares. So if we factor this, x plus 1, x minus 1, the top and bottom cancel out. So then that turns into 1 over x plus 1. Now let's plug in our 1. So if I plug in 1 now, I have 1 over 1 plus 1, which turns into 1/2. So 1/2 is our limit. So factoring, so we're just going to make a little note right here. Factoring can get rid of the problem terms, what we call the problem terms, that create the 0, okay, or that create the 0, like where we can't have the 0. In that case, that was the denominator. Okay, so on 14, so again, if we plug in a 2 in the bottom, 2 squared minus 4, so that's 4 minus 4, that gives us a 0, that creates the problem. So again, we want to look at factoring. If I factor the top, I get x minus 1, x minus 2. On the bottom, we got a difference of perfect squares. So I have x plus 2, x minus 2. So x minus 2's cancel out. I'm left with x minus 1 over x plus 2. Now if I plug in my 2, so 2 minus 1 over 2 plus 2, that is going to give me a 1 over 4. And so that's going to be my limit. Okay, one more example here. All right, so looking at this graph, my limit is x approaches 0 from the left. So again, if I'm approaching 0 from the left, I'm approaching 0 from the left side, that's going to be 0. If I approach 0 from the right side, that is also going to be 0. All right, 0 from either side, well, since it's the same thing, it is going to be 0. All right, let me erase these lines here. All right, as I approach 1 from the left side, so if I approach 1 from the left side, oops. All right, so if I approach 1 from the right side, I'm looking here, my answer is going to be 1 because I'm going that direction there. All right, if I approach 1 from the right side, well, I have to look at this part of the line where the line exists or where the graph exists. So my answer there, my y value is going to be 0. If I approach 1 from either side, well, since these two here don't match, This does not exist. All right, if I approach 2 from the left, okay, so I'm going 2 from the left. I changed my color here so you could see. That answer is going to be 0. If I approach 2 from the right, well, there's no line, there's no graph right there. So that does not exist. All right, let me get rid of some of these lines right here. All right, if I approach 2 from either side, well, again, looking at these two things right here, these don't match. So that does not exist. And if I look at the x value at 0, so I'm looking right there, my y value is 1. All right, so that does it for limits.